students, and welcome to this YouTube live class. I'm Cleeta Ma'am, your mathematics educator for KCET on Unacademy, India's largest learning platform. Students, in today's class we will be learning about complex numbers. We will be having a lecture followed by the MCQ questions and the most repeated questions from the chapter here. So before I start the class, students, let me quickly remind you all to subscribe to our YouTube channel. So do click on the subscribe button and do not forget to press the bell icon to keep yourself updated with all the classes that will be going live on this YouTube channel. Students, in the description below you will find the link to my profile on Unacademy platform. So please do check out the link, that is www.unacademy.com/@Cleeta D'Souza. Do click it right away. You will be redirected to my profile. Do follow me and keep yourself updated with all the free special classes that I will be taking up on the platform there. We will be starting up with the series of batch preparation for courses for KCET preparation students, and all of this is inclusive in the Plus subscription. Now, why it is necessary, or what are the advantages that you will be getting by becoming a Plus subscriber, right? So you will be having the access to the premium content at the very most affordable price, and these will be structured live classes, and you also have dedicated live doubt clearing session. Quizzes at the regular intervals will be conducted, which will help you in analyzing how much you have understood about the particular topic. There are also batch preparation courses. As I said, I will be taking you across the few of the batch preparation courses which are already live, and also you will have the access to all the educators classes, right? 20 plus top educators, 10 plus batches, and 250 plus courses. All of this in a single subscription. To get your Plus subscription, you can also find the link given in the description. Do use the link and do subscribe to our Plus classes, and do not forget to use the code, that is CLEETALIVE, CLEETALIVE. Using this code, you will get 10% off on all these subscriptions. So Champions batch is one of the batches which is running on the platform. Apart from that, students, you can also enroll for the course which is taken up in Kannada language and many other courses. So as you can see, you have the 6 months plan at just rupees 1,688 per month, and the 12 months plan will be at just rupees 1,031 rupees per month. So go ahead, get your Plus subscription, join us in the classes where we will be helping you out to clear your KCET 2021, and you will be coming out with flying colors and good grades. So right then, students, let's begin with the class today, that is a lecture on the complex numbers, right? First of all, what is a complex number and what was the need of complex number, right? You might be familiar with the quadratic equation, that is x square plus 1 equal to 0, right? We were checking with the elementary classes. We would say that this quadratic equation will not have any real root, right? Getting a root of this number in the real number system was not possible. So this gave a rise to the concept, or to the entire study of complex numbers. So basically here, if you could get the root of this equation, right? X square plus 1 equal to 0. This would give you x square is equal to minus 1. So this would imply the value for x here in this case was plus or minus root of minus 1, right? So mathematicians back then, in order to simplify equations of this form, they simply called root of minus 1 as iota, and it is represented with the small letter I, and this is I is equal to root of minus 1. Okay, and this is also called as iota here. So this representation of root of minus 1 as iota, students, gave a rise to the new set of numbers that we will be studying now as the complex numbers. Okay, so complex numbers are nothing but any number which can be written in the form, that is a plus ib where both a and b are real numbers, and iota, that is root of -1. Remember, complex numbers are the numbers which are in the form a plus iota times b, where a and b are some real numbers, and as defined, iota is nothing but square root of -1. Now here in this case, given the complex number, the number a, this is called as the real part of the complex number, wherein the number b is called as the imaginary part. Okay, because this is written along iota, which is root of -1, so we tend to say this is the imaginary part here. So these are the components of a complex number, and this is how we represent a complex number here in this case. Now let's quickly understand when can we say that two complex numbers are going to be equal. So as you can see on the screen, you are given two complex number here, that is z1, which is equal to a1 plus iota times b1, and z2 here in this case is a2 plus iota times b2. These two complex numbers are said to be equal if a1 is equal to a2 and b1 is equal to b2. Only in this case we can say the two complex numbers are going to be equal. Or in the other way, if I say two complex numbers are equal, what do we infer immediately? The real part should be equal of both the complex numbers, and the imaginary part of both the complex numbers should also be equal here in this case. Now here are the few of the algebra of the complex numbers, that is addition, subtraction, multiplication. So let's quickly understand the few of the properties that will hold true even in the complex number system. Right? Suppose if we have two complex numbers, that is z1 and z2, right? Then their sum, z1 plus z2, will be of the form a plus c plus iota times b plus d. As you can observe, we are adding the real parts and we are adding the imaginary parts together here. Right? So the sum that we obtain, z1 plus z2, will also be a complex number here. So the closure law holds true in this case. That is, sum z1 plus z2 will also be a complex number. The commutative law will also hold true here. That is, z1 plus z2 will be equal to z2 plus z1. The associative law will also hold true. That is, z1 plus z2 plus z3 will be equal to z1 plus z2 plus z3. We also have the identity element here in this case for the addition of complex numbers. That is, we have a complex number of the form 0 plus iota into 0. This is called as the additive identity for the complex number here in this case. And there is also the additive inverse, that is, whenever you are given a complex number z, its additive inverse will be minus of z. That is, minus a plus iota times minus b. When you add them both, you will have the additive identity, that is 0. So minus of z is called as the additive inverse here in this case. So these were the few properties that are satisfied with the addition of complex numbers. Now coming down to the difference of complex numbers, right? Difference of complex numbers can be written in terms of addition itself. z1 minus z2, we can express this as z1 plus negative times z2 here. Yes, so this was about the difference between the two complex numbers. The next concept that we have is multiplication of two complex numbers. Suppose if you have the complex number given z1 here, which is a plus iota times b, and z2 is c plus iota times d, and these two are complex numbers, then the product z1 into z2 here in this case will be equal to ac minus bd plus iota times ad plus bc. Okay, so if I have to give you the, it's kind of similar that how we do with the binomial multiplication. So if I have to take a plus iota times b multiplied with c plus iota times d, so multiplying a into c, and then you have a into d into iota plus iota b into c, and then you have the last term here, b into d into iota square. Now what is the value for iota? Iota is root of -1. When we square, it is going to be -1 right? So I'm taking all the terms without iota together, so that is going to be AC minus BD plus iota into, here in this case, AD plus BC. So this will be the product. This is how we multiply, and the result that we are going to use is iota square value is equal to minus 1 here. Now these are the few properties which are related to multiplication of complex numbers, right? So as we have seen, the product of the two complex number, this is also again in the standard form of a complex number, that is in the a plus iota times b form. So this is also a complex number here. So the closure law is clearly true here in this case. Even the commutative law, that is z1 into z2 will be equal to z2 into z1. The associative law will also hold true, that is z1 into z2 into z3 will be equal to z1 into z2 into z3 here in this case. There is the multiplicative identity that will exist, that is the complex number 1 plus iota times 0, or you could just take it as 1 itself. So this is going to be the multiplicative identity such that z into 1 is equal to z, and this is true for every complex numbers here in this case. The next property that we have is the existence of multiplicative inverse, right? So suppose if we have a complex number z is equal to a plus iota b, the multiplicative inverse will be of the form a divided by a square plus b square plus iota times minus b divided by a square plus b square, or this value could be simply denoted as 1 by z or z inverse here, such that when you multiply z with the multiplicative inverse, you will get the multiplicative identity, that is nothing but equal to 1, right? So we can use this form given here, students, to get the multiplicative inverse. If not, in the upcoming classes we will be learning the concept of modulus and conjugate of a complex number. So we will be learning one more formula there that would be quite faster when compared to using this relation to get the multiplicative inverse. Now the next law that is satisfied here is multiplication is distributive over addition. So as you can see, z1 into z2 plus z3, this will be equal to z1 into z2 plus z1 into z3, and the multiplication of z1 plus z2 into z3, this will be equal to z1 into z3 plus z2 into z3 here. So the distributive law also holds true here in this case. So these are the few properties that we have with the multiplication. Now the next basic algebra that we have is division of two complex numbers. Suppose if you have two complex numbers z1 and z2, where z2 is not equal to 0, right? Then the quotient here in this case is defined by z1 into 1 divided by z2, that is z1 multiplied with the multiplicative inverse of z2 will be the quotient for the division here in this case. The next concept that we are going to do is the powers of I here. Okay, this is an important concept, and at times we see the repeated question coming up with the concept of powers of iota here. First of all, we have defined iota as root of minus 1. So in order to understand this concept, students, let me square this iota square. What is the value going to be? This is going to be minus 1 here. What about iota cube? Iota cube is nothing but iota square into iota, so this is going to be minus iota. Iota raised to the power 4, right? This is going to be iota square the whole square minus 1 the whole square, so this is going to be equal to plus 1. Similarly, if you check for the values of iota raised to the power 5, to the power 6, power 7 and power 8, you will observe iota raised to the power 5. This is nothing but iota raised to the power 4 into iota, right? And what is the value for iota? Root of minus 1. So this will be nothing but minus 1. Yes, use the same idea. Express them as the multiples raised to the power 4 into the remaining value. So you will have this as iota to the power 4 into iota square. Here this is going to be iota to the power 4 into iota cube. So this will be minus iota. iota raised to the power 8. So this is going to be equal to 1 here in this case. Yes, so as you can observe, after every fourth element here, number or the power, the values are going to repeat. So there is a general form given whenever iota is raised to any power that is a multiple of number 4. In that case, the value here in this case will be equal to 1. So as you can see, iota raised to the power 4, iota raised to the power 8, all these values are equal to 1. K could be a positive integer or a negative integer. Okay, there's no issue with that. Okay, whenever iota is raised to a multiple of 4, it will be equal to 1. Whenever iota is raised to the power that is 4k plus 1, this will be equal to iota, right? This is nothing but iota raised to the power 4k into iota, right? Anything raised to the power 4 will be equal to 1, so you will have this as iota itself. And the next one, iota raised to the power 4k plus 2. This is iota raised to the power 4k into iota square. So the value here in this case will be equal to minus 1. Iota raised to the power 4k plus 3, this will be iota raised to the power 4k into iota cube. And what is the value for iota cube? Iota cube is minus 1. So these are the general forms that you could remember, students. Okay, let me quickly revise. For any integer k, iota raised to the power 4k will be equal to 1. Iota raised to the power 4k plus 1 is equal to iota. Iota raised to the power 4k plus 2 is equal to minus 1. Iota raised to the power 4k plus 3 will be equal to minus iota. Yes, I hope you guys are familiar with the theory that we just dealt with. So let's do few of the question now, students. So this is the first question for the class. If 4x plus iota into 3x minus y is equal to 3 plus iota into minus 6, where the values for x and y are real numbers, then what is the value for x and y here in this case? So let me give you all 30 seconds of time. Please do give a try to this question. Leave your answers in the chat box. Let me check if you guys managed to get the right answer here, students. So here we are using the equality concept between the complex numbers, right? Whenever we say two complex numbers are equal, we have the real parts being equal and the imaginary parts being equal. So if I have to take the real parts equal here in this case, so what do we have? 4 times x, this is equal to 3, and with the imaginary part you will have 3 times x minus y, this is equal to minus of 6. So simplify the equation. 4 times x is equal to 3. So what is the value for x? X will be equal to 3 by 4. So as you can see in the options here, you have only option B where the value for x is given as 3 by 4. So this will be the right answer. So let's verify what would be the value for y. Y would be nothing but 3 times x plus 6. So this is 3 times 3 by 4 plus 6 here in this case, which is 9 plus 24 by 4, and this value is nothing but 33 by 4. So clearly the option B is the right answer for the question given here. So this is the next question now, students. Question on the powers of I concept. So you have the series given here, that is 1 plus iota square plus iota raised to the power 4 plus iota raised to the power 6 and so on up to iota raised to the power 2n is equal to which of the following? Is it a positive value, a negative value, 0, or cannot be defined? Please give a try to this question and give a try and leave your answers in the chat box, students. What do you think would be the right answer here? Yes, any guesses? Think about the powers of I, right? Iota raised to the power a multiple of 4, this is equal to 1. Iota raised to the power 4k plus 2, since all are even numbers, right? This is equal to minus 1. These two values need to be used in simplifying here. Okay, so let me explain the solution here, students. right? So number 1 as it is, iota square, this value is minus 1, iota raised to the power 4, this is plus 1, iota raised to the power 6, right? This would be minus 1 and so on. What is the last term that we are given? Iota raised to the power 2 times n, right? I can take this as iota square raised to the power n, which is going to be minus 1 raised to the power n. So as you can see, we may lose out certain terms here, okay, all of them are going to cancel out and become 0, but we do not know what will be the value for the last term here, that is minus 1 raised to the power n, unless or until the value for n is defined, right? So the answer here in this case is going to be option D, that is, this cannot be determined. Unless or until the value for n is given, students, here we will not be able to make any guesses with what will be the value for the given series here. Yes, I hope you guys are following with the solution here. If not, please do leave your doubts in the chat box there. So let's proceed with the next question now, students. This is the next question. What is the value for 1 plus iota raised to the power 4 into 1 plus 1 by iota raised to the power 4? Give a try to this question, everyone. What do you think is the right answer here? So I am simplifying the second term here, 1 plus iota raised to the power 4 into 1 plus 1 by iota raised to the power 4. I am writing this as iota plus 1 raised to the power 4 divided by iota to the power 4. Now iota to the power 4, this is equal to 1, and what do we have the terms here in the numerator? 1 plus iota raised to the power 4 into 1 plus iota raised to the power 4. So this will be nothing but 1 plus iota the whole square, and I am taking this raised to the power 4, right? So let's expand 1 plus iota the whole square. This is going to be 1 plus iota square plus 2 times iota, and this term here is raised to the power 4. Iota square value is equal to minus 1. So 1 plus minus 1, this will be equal to 0. What remains is just 2i. So this will be 2 times iota raised to the power 4, students. So 2 raised to the power 4, this is equal to 16 into iota raised to the power 4. Iota raised to the power 4, what is the value? This is equal to 1. So the answer for the given question will be equal to 16. The option D is the correct answer for the question here. Right then, this is the next question that I have for the class. Minus 5 times iota multiplied with 1 by 8 times iota is equal to which of the following option? That is, we are expressing the given equation in the standard form of a complex number, that is in the a plus iota b form. So simplify this question, students, now and give me your answers. What do you think? Which of the option is going to be the right answer here? So let's multiply, right? Let's multiply the numerical values. Minus 5 into 1 by 8. So this is minus 5 by 8 into, you have the iota into iota, which is iota square. What is the value for iota square? This is minus 1. So the value here in this case will be 5 by 8. 5 by 8 is a real number, right? So we have the real part, we do not have the imaginary part. So I am adding on the imaginary part, that is iota into 0. So the right answer for this question is going to be the option D here, that is 5 by 8 plus 0 times iota. So this is the next question, students. I want you all to give a try. So let me quickly give you all the simplified version, right? So minus root 3, let's retain it as it is, right? Root of minus 2, you can take it as root of minus 1 into 2. So this will be iota times root of 2 multiplied with 2 times root of 3 minus iota. So please multiply these two terms here and give me the answer. Which of the following option will be the right answer here in this case? Right, let me multiply. So we will have minus root 3 into 2 times root 3. So this is minus of root 3 into root 3 will be 3. 3 into 2, that is going to be 6. Right, minus root 3 into minus iota, this will be plus iota into root of 3. Iota times root of 2 into 2 times root 3. This is going to be iota into 2 times root of 6. And then we have minus iota square root of 2. So let's take iota square value is equal to minus 1. So this term here is going to be plus root 2. So let's pair the real values together. And you have root 3 and root of 6. Right? So I can take root of 3 common out. So this will be 1 plus 2 times root of 2. So the right answer for this question is going to be the option D, students. This will be the right answer for the product of the given two complex numbers here. Yes, I hope you guys are following the class here, students. If you're liking this session, do not forget to give me a thumbs up. Yes, and if you wish to follow more of my classes, do check out for the link to my profile given in the description below, which is www.unacademy.com/@Cleeta. Students, the plus classes are already live on a platform, and as I informed you, we will be coming up with many more batch preparation courses. To get your plus subscription, please do check out for the link for the plus subscription given in the description of this class. And do not forget to use the code, that is CLEETALIVE, CLEETALIVE. Using this code, you will get 10% off on all the subscriptions here on the platform. So we have a few of the best plans for you on the screen. That is 6 months plan will be at just rupees 1688 per month, and the 12 months plan will be at rupees 1031 rupees per month. So do use the link which are shared with your students, and do not forget to use the code, that is CLEETALIVE, to get 10% off on all the possible subscriptions here on our platform. Get your plus subscription today and join me soon in my plus classes, and also do not forget to join me in my special classes where we will be discussing various concepts which are necessary for KCET examination. Students, we have started with a free practice course on our platform, that is the Daily T20. So this practice course will be live every day, and you will be having a practice session coming up. So do get yourself enrolled to this practice session and start preparing for your KCET examination. Right then, it's time for me to wind up this class. So take care everyone. I shall see you soon with one more session. And together, let's crack KCET 2021-2022 with Unacademy, India's largest learning platform.